trigonometry, the form Rcos theta plus or minus alpha and Rsin theta plus or minus alpha. We can write this mixture of sine and cosine terms either just in terms of sine or just in terms of cosine. And this can be quite useful for working out things like the maximum of this function here, or its minimum, or the angle at which you get the maximum or minimum, and so on. So we have theta here in radians. Here's theta. So we need to determine the value of r and the angle alpha. Sine theta plus or minus alpha, this is a compound angle. And we've got cos theta plus or minus alpha. Again, we have a compound angle. In the formula book, on page 3, we have the following two compound angle formulae. When expanded, they look like this. And we're going to use these forms to expand sine a plus or minus b or cos a plus or minus b. Example 1. Let's write this in terms of just sine. So using the compound angle formula for sine, we can expand this like this. Remember, there is an r here and here. So we have a sine theta term here, and we have a sine theta term here. This sine theta term is multiplied by 3, that's the coefficient of the sine theta term. This one is multiplied by r cos alpha. So comparing the coefficients, 3 is equal to r cos alpha. So that gives us one equation to work with. 3 equals r cos alpha. We can do something similar with the cosine terms. This one has a coefficient of 4. This one here, which is multiplied by r sine alpha. So the coefficient of the cos theta term here is r sine alpha. So 4 is equal to r sine alpha. So we have these two equations. To work out the angle alpha, we need to divide these two equations like this. That's 4/3. The r's will cancel. Sine over cos is tan. So tan alpha is 4/3. And then from the calculator, inverse tan, 4/3, we have alpha is 0.927 radians. The easiest way to work out the value of r is to apply Pythagoras' theorem to these two values. Here is the proof behind why we're using Pythagoras' theorem, and this proof, or this working out, does not need to be shown in exam situations. So, I've made cos alpha and sine alpha the subject of each of our two equations, and using this standard identity, so we've got cos squared alpha, so we're squaring this. Sine squared alpha, so we're squaring this. And adding them will equal to 1. You just multiply the brackets out here and then multiply by r squared throughout. And you can see the Pythagoras' theorem result that we were using before. So r is equal to 3 squared plus 4 squared, and we're going to square root. So all of this you can skip out, just show this. So our final answer is written like this. So we had a mixture of sine and cosine terms. Now we have written our final answer in just sine. Now the maximum of this function can be obtained by looking at this value here. we know that sine has a maximum of 1 and a minimum of -1, but this is a times 5 stretch in the y direction. So we know that the graph here will have a maximum of 5 and it will have a minimum of -5. So let's say we want to determine the angle theta for which we have this maximum where y is equal to 5. Well, we know that sine has a maximum at pi over 2. So this angle needs to be pi over 2. All of this needs to be pi over 2. So there's the angle, and it's equal to pi over 2. And solving this simple equation gives us theta is equal to 0.644 radians. This is a graphical interpretation of the problem. So you're looking at the curve here that has this equation. It's just in terms of sine. There's a maximum of 5, a minimum of -5, and the maximum there occurs at this angle when theta is 0.644. Example 2. This time we're going to write our terms here just using cosine, so just in terms of cos. So using the compound angle formula for cos, we have this. Again, remember we have r here and here. And then we can see the cosine term here. This one has a coefficient of 4, this one r cos alpha. So we can say that 4 is equal to r cos alpha. There. And looking at the sine term, we can say that 3 is equal to r sine alpha. And then dividing these two, this equation divided by this one, so sine over cos is tan, the r's will cancel, 3 over 4, inverse tan 3/4, we have our angle in radians, and using Pythagoras' theorem on these two values gives us 5, which we can write like this. Example 3, we're going to write this mixture of sine and cosine terms just in terms of sine. So using the compound angle formula, we have this. So sine x, here is sine x. So from here we can say that 3 is equal to r cos alpha here. We have a cos term here and here. So we can say 2 is equal to r sine alpha. Sine over cos is tan. So tan is 2/3. So this is alpha. So we're working out alpha here by doing inverse tan 2/3 on the calculator in radians mode. And applying Pythagoras' theorem to work out r, it's better to leave this in third form. So we have this. So we've worked out r and we've worked out alpha. So the maximum of the graph is when y equals √13, and the minimum will be when y equals -√13.